So what is my aim to tell you? And if we consider the figures in India only by 2030, the urban areas are expected to house 40% of the Indian population, and which will lead almost 75% of the national GDP. So that is the reason behind the unprecedented rush from the countryside, that is mobility between the countryside and the urban areas. So now the question is, why should we be worried? It's a good sign. People are migrating from countryside to the urban side. Everywhere development is okay, fine. So why should we be worried? Yes, because in all cases, urbanization always accompanied by an increase in imperviousness cover, and increasing impervious cover in any area will affect the urban flooding and the urban heat island effects. Not only that, many urban rivers are also slowly drying up. If you visit many urban streams, and they are getting slowly drying up, the main reason is this expansion of this or inadequate surface water and the groundwater exchange method. So quickly, for this class, I will take up these two issues. There are many factors. I will try to cover only these two issues by another 30 to 35 minutes. Then I will take up some questions from you. So first issue, I want to take up urban imperviousness. What is the role of directly connected impervious area? And the second one is hyporic corridor. And why this exchange of groundwater and the surface water and the groundwater is so important in urban areas. So before I start, I must tell you, never ask question any fund to the system. System is okay. Urban drain, everywhere the drains are okay. This is the only the way. We need to construct drain. So now, how to give a local based solution to the existing system? System is okay. So first, urban imperviousness. What is the conventional approach? Normally we follow the conventional approach. Everywhere we find the total runoff or the peak runoff rate by the rational formula. This is a very commonly used applied method, rational formula. And everybody we know, every day we do some exercises. What is the rational formula? Q is equal to C into I into A. That is total peak runoff coefficient, rainfall intensity into the drainage area. This is very commonly applied method everywhere. But I would like to stress on the what are the limitations of this rational formula. First one, the method accounts only give you the peak, the point value, peak runoff. It never give you the total complete hydrograph. Peak value, only peak value. Second one, it cannot account for the retention storage before the runoff begins. It never assumed or it never considered how much of the water is already retained in the area, how much of the water already trapped into the ponds, lakes, wetlands. It never considers. Third, it assumes the same amount of the rainfall across the area. The I is average rainfall intensity. It assumes a same intensity of the rainfalls is occurring or happening over the. It is very much unrealistic. If the rain starts in the morning, the intensity changes as there is a temporal changes, also there is a spatial changes. So if you consider an average rainfall intensity, it is not real. It is unrealistic. And the fourth one, very important, the assumption in the rational formula, the runoff coefficient. The runoff coefficient we are picking up, it is again, I would say, it is also not real. It is not realistic. Why? Because it never considered the varying soil moisture condition. Why I am telling? Today there is a rainfall, let us say, of 100 millimeter. If the 100 millimeter rainfall occurs today in the mid of July, the amount of the overland flow, you can see If same amount of rainfall would happen at the beginning of the monsoon period, you will not find the same amount of the rainfall. If the same amount of the rainfall happens at the end of the monsoon period, it will be different. What is the reason? Moisture condition, the saturation points is different. So not only that, place to place also it may varies. So there is a variation both temporarily and spatially as well. So that is not considered in the rational formula. So these are the some limitations. So keeping in view the limitations of formula, what the recent research says, what the modern research says. Modern research, they are readily available to overcome the rational approach. Because any urban areas, as we are talking on the smart city, any urban areas in general composed of two factors. One is impervious area, another one is pervious area. Everyone we are aware about what is pervious area, what is impervious area. Now let us try to understand this figure. Here we have considered a small grid, small parcel in the urban drainage network, small parcel. Now if we look into that, why it is not pointing? Okay, this cursor is visible, no? Okay, now it will work. Okay, leave it. So now see here, this is the grid or parcel. In this parcel, what are the different contributions of different area? The shaded area, this shaded area, all these shaded area are impervious. Impervious. Let us say the shaded area are impervious, and this white portion, blank portion, these are pervious. Now in this shaded area, this is impervious area, but they are directly connected to this drain. So we will call it impervious area directly connected. That is DCIA, directly connected impervious area. The impervious areas that are directly connected to the main drainage node, these are impervious area but directly connected. But the most important part is impervious area which are not connected to the drain. One volleyball playground or courtyard which is completely impervious, but it is not connected to the drain. So this will be under the category of impervious area but not connected. So that is why it is termed as isolated impervious area, IIA. The impervious area that need to travel through the pervious area to get to the drainage network. This shaded portion, impervious area, but it is not connected to the drain. So to connect the drain, it need to pass over the pervious area, and rest of the things are pervious area. Now keeping in view, now put it into the temporal variation, that is before the saturation and after the saturation. So now if you just do little bit exercise, you can construct a that is response function for that, and ultimately what are the contribution, what are the runoff contribution for each part, that is DCIA, IAA and pervious area. Pervious area, again there are two types of contribution. One is excess rainfall pervious area, that is when the soil is fully saturated, then if the rainfall occurs, all the rainfall will, you can imagine, you can see as a overland flow, that is excess rainfall. That is why pervious area, over the pervious area, that is there is, if you find the overland flow over the pervious area, that is excess pervious area. And infiltration, INPRV, that is infiltration pervious area, that is during the dry season, if the same amount of the rainfall happens on the pervious area, you will not find overland flow, you will find a base flow, infiltration, base flow, and that is known as infiltration pervious area. So my aim was to distinguish in between what the scenario before saturation and what the scenario after the saturation. Why I have done this? Now you look at the most commonly method adopted for researchers. It is SCII number, that is soil conservation of service. They have developed a curve number method, and this method is recommended by the Central Groundwater Board of India, and it is suitable method since it. So I need 2-3 minutes time for you to understand this figure. What is this figure? This is a hydrograph. Hydrograph, that is time versus rainfall intensity. And this curve denotes the infiltration line. That is above who is the shaded portion denote the runoff, overland flow. And below this line, infiltration. So now we will try to understand this figure. This P denotes rainfall, E denotes excess. So P denotes, this shaded portion above this line is excess rainfall, that is the overland portion, only overland portion. And this denotes, so this excess rainfall, can you please check this one so that I can use this pointer? Orbana? Okay. So I will go there. So this is the hydrograph. This portion is excess rainfall. Now try to understand, this excess rainfall will be always equal to or less than total rainfall. Are you agree with me? Excess, that is overland runoff. Runoff cannot be more than the rainfall. Rainfall is P. How much will be the runoff? Overland flow. Obviously, it may be equal to P or less than P. That is why I have said the direct runoff is always less than or equal to the depth of the precipitation. Agree? Number 2, after the runoff begins, some amount of the water always retained in the watershed. If there is a rainfall, just immediately at that time, you cannot see runoff. Some water will be stored, and that amount of the storage is always less than the maximum water storage. Number 3, already there are some storage due to the initial abstraction. So what is the potential runoff? So what is the potential runoff? The total rainfall minus this initial abstraction. So now the hypothesis of this SCS method is the ratio of the actual to the potential in both cases are equal. PE, actual, excess rainfall, and this is potential, P minus IA. So this is in terms of rainfall, and this is in terms of storage. This is actual storage, and this is maximum storage. The actual by potential is equal to actual by potential storage. Agree? And the continuity equation says that total rainfall is equal to excess rainfall, initial abstraction, and storage. These are agree? So this is continuity equation, this is the hypothesis. By combining these two, one can find out the total runoff. And total runoff is associated with the term maximum storage. And under Indian conditions says that this maximum storage is, the initial abstraction is 20% of the maximum storage. And ultimately, if you substitute these values here, ultimately total excess runoff, that is runoff, overland flow, can be expressed in this way. Now here this S term, this storage is very important. If there is a rainfall, how much water will be stored into that area, and only after that we will be able to find what will be the overland flow. So this storage is interlinked with a curve, and this is this graph is known as has been designed in between rainfall versus direct runoff, and there are many inclined lines, and this is very popularly for the field engineer, that is SCS-CN curve, CN value. And this inclined line, this CN value has been designed in such a way based on the impervious surface. 100 denotes glass surface, maximum impervious. This surface is impervious. So the CN value, that is curve number is 100 for maximum. Similarly, in case of sand, in case of sand, it is 40 because it is pervious. So accordingly, it has been designed. And here, this storage is equal to 25400 divided by this curve number minus 254. So why I am telling you, just we need to keep it, all these things in our mind so that we can do a small exercise. And before that, this curve number is based on some land use descriptions. 4 types of soils are there from hydrological point of view, that is. And what are these 4 types of soils? Type A, type B, type C. Type A is lowest runoff, that is more impervious. Moderately low runoff, moderately high runoff, and now if you see these are the land description. This has been not considered in the rational formula, but in SCII method, this has been considered. For example, commercial and business area. Commercial and business area, if your place is in B type of soil, curve number is 92. If your area is C type of soil, then the curve number is 94. So it will be easier for you to pick it up. Let us try to do a small exercise. Example study. Because why I am telling you, this is a very small area. If we understand these things, it will be helpful for us. What we need to do for a realistic solution of the urban drainage. So for example, example study, what it is stated, compute the runoff from a 300 millimeter, yesterday it was 300 millimeter rainfall. Example, compute the runoff from a 300 millimeter of rainfall over an urban area. The hydrological soil group is 50% group B and 50% group C. It happens in the month of July, when the AMC is 2 means average condition. Antecedent moisture condition is 2. 2 means average condition. AMC1 is dry condition, AMC3 is wet condition. So under AMC2 condition. And the land use pattern just let us try to understand. 40% residential area having average 30% impervious. 12% residential area having more than 65% impervious. Consider an area, just try to imagine, consider an area. In that area, 40% residential area which are having only 30% impervious. My house is there, his house is there. Okay? My house, it is 100 or let us say 1000 square feet. But the entire 1000 square feet is impervious, completely terrace. In his case, out of 1000 square feet, only 50% is terrace, rest of the is different courtyards or other things, gardens, lawns. Okay, so that is why let us try to understand 40% residential area having average 30% impervious. 12% residential area having more than 65% impervious. 18% pavement road will be there. 16% open land. 16% is open land, but what kind of open land? Out of the 60%, 50% fair grass cover and 50% good grass cover. And the remaining, the 14% is parking lots, commercial places, plazas, office, etc. So this is the nature of the land. I repeat for you. Consider an area where there is a 300 millimeter rainfall. I need what will be the runoff, overland flow. Under MC condition 2, average moisture condition 2. And the soil type is 50%, let us say 50% group B, 50% group C. And the land use pattern is given here. So for that, first of all, I need a mean curve number, average curve number, that is known as the weighted curve number. How to find? For example, first one is residential area. That is residential area 30% impervious. Residential area 30% impervious. So why this SCS curve number method is so popular?